Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome to our last tutorial for the work physiology and measurement subject. Yep, today we will discuss about the physical work environment model. So before we start this tutorial, let's pray together. Pray start. Enough? Okay, before we move, in this tutorial, we will discuss about the objective of tutorial, and the second is the input and the output of the tutorial, and the third is material discussion or the main material, and for the last is we will do the exercise. Okay guys, from this illustration we know that in real industry activities, the physical work environment can affect the work directly or indirectly. For example, there is a noise that occurs from the heavy equipment that transfers the material from the one place to the others. Then you can imagine if you are one of the workers on that place, for sure you will feel uncomfortable because the noise that is not suitable with the standard and also the dust from the material. Then it will affect to your performance if you are not wearing some personal protection equipment, I guess. In the other case, we know the other physical environment factors that influenced someone's performance. There are light at work, there are certain standards for each job or room, and then temperature and humidity that can affect someone's air circulation condition. So from this, I hope you understand what we will analyzing in this tutorial. Okay, let's move. So the objectives of these tutorials are: first, you be able to measure lighting, temperature, noise, and vibration by using the application. And for the second is you be able to determine the effects of noise, temperature, lighting, and vibration. And for the last is you be able to analyze the design of the optimum physical work environment. Alright, for the input and the output of in this tutorial, for the inputs are some as previous tutorial, you should collecting data, operators, demographic and descriptive data. And the second is noise, temperature, and exposure measurement data. And for the third is output data summary. Then for the output of in this tutorials are analysis of the comparison of operators' performance with the treatment or different physical work environments. And the second is analyze all the physical work environment factors such as noise, temperature, and lighting. For the last is you can give the recommendation based on the performance and physical work environment result. Okay, let's move to the main material. Okay, there is some definition about the physical environment. Based on G 2000, the physical environment is all physical factors that together is a physical atmosphere that includes a workplace. Then from Nawawi 2001, we know that physical work environment is everything that is around workers who are influential in carrying out assigned tasks, for example like lighting, air temperature, space, security, cleanliness, or music. Meanwhile, Sihombing 2004 said that physical environment is one of the elements that must be empowered by an organization to create a sense of comfort, peace, and can increase good work results to improve the performance of the organization. There are a lot of physical factors that you see on your screen, but in this tutorial we will only discuss about lighting, temperature, noise, and vibration. Okay, first we will talk about lighting. The definition of lighting is a stimulus for vision. Actually, the lack of lighting or too much intensity of lighting can cause fatigue, headache, dizziness, and increased risk of accidents. We can use lux meter to measure the lighting like this. So there are some characteristics of a good lighting. First is enough amount of lighting. It means that rays or light is quiet, not too dim or not too dark. And for the second is not glare. Not glare, it means glare is caused by excess brightness. For example, uh, of using the lights or sun directly. For the detail, we will discuss on the next slide. And then for the third is good and proper contrast. It means significant difference in terms of color, form, size, and etc. The contrast is made colors between one object and the other object has clear differences. And the fourth is good and proper brightness. The level of luminance or brightness in a room is not too bright or not too dim. For the fifth is good and proper color selection. The suitable chosen color that is comfortable for your eyes. For example, if the color lamp on the class and the color lamp on the classy restaurant has the same color, I know it will be not comfortable for the students. So we know that the color of the lamp should be adjusted to the worker activities. Then, next we will get to know with glare. Glare is a stimulation produced by the luminance or brightness in the visual area, which is large enough that the eye can adjust. Based on the source, glare can be divided into two. Direct glare, which is generated from a light source that is not sufficiently protected in the visual area, and then for the second is indirect glare, which is generated from objects that have high luminance and is reflected by surface in the visual area. Meanwhile, based on its effect to humans, glare can be divided into three. First is discomfort glare, which causes subjective feelings disturbance, usually eye strain, and for disability glare, which causes a decrease in vision ability. And the last is photostress glare, cause a delay in restoration of the visual system. Okay, because humans have a limitation, so there is a threshold limit of lighting based on the standard of Kaplan KSRI number 261 regarding the health requirements of the work environment. There is a minimum lighting level recommended. For these activities, groundwork and not constantly, the minimum level of light is 100, and for the groundwork and continuous, the minimum level of light is 200, and for the routine work, the minimum level of light is 300, and then for the making work a bit smoother, have a minimum level of light is 500, and for smooth work, have minimum level of light is 1000, and very smooth work have a minimum level of light is 1500. Didn't cause shadows, and for the detail work have a minimum level of light is 3000 lux, doesn't cause shadows. So for the descriptive, you can see on your screen for each activities. And then as you read on the model, there are two types of lighting measurement. It was a local and general. So in this slide, we will know how to measure it for the general one. For the general measurement means measurement to the whole place or just in one room. So the steps to measure the general one are: first, you should determine the area of the room first. Then measure according to the classification as shown in PPT, and for the instrument is placed as each intersection of the point. After all points are measured, then they are averaged. to find out the amount of lighting in the room. So the specified distance is different based on the area of the room as follows. Like if the area of the room is less than 10 square meters, so the point of the intersection of the horizontal line or length and width of the room is at a distance of every 1 meter. If the area of the room between 10.1 square meters to 100 square meters, so the intersection point of the horizontal line and the length and width of the room is at a distance of every 3 meters. Then if the room's area more than 100 square meters, so the horizontal intersection of the length and the width of the room is at a distance of 6 meters. Okay, next factor is vibration. Vibration can be defined in several senses, such as mechanical oscillations, movement of particles around the equilibrium that gives an effect of the health, comfort, and performance of a person. So we can use a vibrometer to measure the vibration level. Same as before, we know humans have the limitation. There are some threshold limitation of the vibration exposure. Actually, vibration is influenced by the frequency and intensity of the vibration itself. Frequency is a measure in hertz, and vibration intensity can be measured in various ways. For example, high amplitude, acceleration, speed, and the height of vibration placement. Based on the table, there is a vibration limitation based on working time that is exposed by vibration. Actually, in the SKI laboratory, there is a real vibrometer like the picture that you see on your screen, but because this pandemic vibes, we can't try it directly, so don't be sad because I will let you know how to use it, okay? First is determine the vibration area to be measured, and the second is place the sensor to the location of the measure object or machine, and the third is observe the scale measured on the vibrometer. Then the last is hold the hold button when the measurement scale will be set by the operator. Okay, next factor is temperature. Temperature. The definition of temperature is a physics quantity which is a measure of the heat or the coldness of a condition, and we use thermometer to measure it. Actually, each level of temperature will have a different effect of human performance. For first is 49 degrees Celsius. Temperature can be held for about 1 hour, but far above abilities, physical and mental. For 33 degrees Celsius, mental activity and comprehension begin to decline and tend to make a mistake in work and physical fatigue. And for 24 degrees Celsius, this is the optimum grade for working condition. And then for the 10 degrees Celsius is an extreme physical behavior began to appear. According to Sutalaksana 1979, that number labor productivity will reach the highest level at the temperature of 24 until 27 degrees Celsius, but the best temperature condition when doing the work is 24 degrees Celsius. Okay, I know that all of you know how to use the thermometer yet. So the steps are, the first is place the thermometer in the place that you want to measure, and then waiting for the output results for up to 5 minutes. For the last is observe the scale on the thermometer. Okay, the last but not least is noise. Okay, Noise is a pressure which can be detected by ears or longitudinal wave that propagate through media such as liquid, solid, and gas. Noise is unweighted sound that operation and activities to the level of a certain time that can cause human health problems and environmental discomfort. In the research of Firdaus et al. 2009 stated there are three aspects that determine sound quality of interference of humans. Namely, first is the length of the time of the sound was heard. The second is intensity is usually measured in decibel, which shows the amount of low energy per unit area. And the third is the sound frequency, indicating the number of sound waves arriving at the person's ears per second. That means the number of vibration per second or hertz. For example, when the work in the production system with a machine that works continuously, it will make a little noise and become less focused when working, so that it can make fatigue and dangerous work stress. So we use sound level method to measure it. So there is a standard noise level according to Kementerian Lingkungan Hidup Republik Indonesia based on the type of area and environmental activities that you can see on your screen like this. And then besides based on the type of area and environmental activities, noise limitation is determined by prolonged exposure per day in hour, like on this slide. Okay. You can take note it is prohibited to be exposed to more than 140 decibel, although momentarily. Okay, we will move to here's how to use a sound detector, namely sound level meter. First is you can select the sound level meter position selector adapts to the type of noise, and for the second is select the noise intensity range selector, and then determine the measurement area directed to the source of sound, and fourth is measure sound pressure level decibel A for 10 minutes for each measurement with recordings performed every 5 seconds. Then for the last is write the measurement result and calculate the average noise. Okay, we will move to the exercise section, especially for the noise factor calculation method. In this tutorial, we will use this simple technique to collect the noise measurement data by measure the sound pressure level decibel A for 10 minutes for each measurement, recording performed every 5 seconds. Okay, after that we will get the data like you see on the table, like that. And after that we should determine the maximum value and the minimum value between those data. Then from that maximum and minimum value, we can get range by calculating maximum value minus by minimum value, and we get the R now value is 19.6. Okay, like this. And then for the second is then to get the number of classes or K, we can use the formula like that. Then we got the K value is 8. So there is an 8 class interval on this case. After that, we can calculate the interval of the class. This is I value get from R divided by K. So we got 2.48. Then with this interval value, we can make the noise interval like this table. After that, we can calculate the frequency of each distribution. like this table. Okay, from this table we can know the interval value, then the median value of the interval value are named by Ln, and the frequency of each interval named by Tn. Okay. Oops, this step is not finished yet. For the last is we can calculate the LTM5 by using this formula. On the formula, we know that there is a sum of calculation that using ln, okay, and Tn value from first interval until 8th interval. Last, from that long calculation, we got 57.246 decibel A for the level of noise. Okay, then Alhamdulillah we have finished this tutorial video section. I hope all of you can get what I have explained, and please take notes for the part that you still confused, then ask directly in your tutorial class. Thank you for your effort, your time, and your dedication for these 10 modules. See you on the RSKE tutorial. Thank you. Matur nuwun, sukran, gomawo, dan terima kasih.